So let's see this question. This question says given the following series. So there we are given the series. It says calculate the sum if all the numbers divisible by 5 are removed. So this is one of those questions that challenges many learners. So let's see how to do it. It says calculate the sum if all the numbers divisible by 5 are removed. So let's understand this. If they say a number is divisible by 5, it means if you divide that number by 5, it will give you a whole number and not the decimals. Let's say for an example, 10 and then 20 and then 2 and then 1. Let's see here. If you say 10 divided by 5, it will give you 2, and then 2 is a whole number. So this means 10 is divisible by 5. And then if you say 20 divided by 5, it will give you 4. So this means 20 is divisible by 5. But what if you say 2 divided by 5? If you say 2 divided by 5, it will give you decimals. So this means 2 is not divisible by 5. And then if you say 1 divided by 5, it will also give you the decimals. So it means 1 is not divisible by 5. So now let's see how we are going to do this question. Remember that this is arithmetic series. Arithmetic series is identified by having the common difference. As you can see that moving from 5 to 8 we add by the same number, and then moving from 8 to 11 we add by the same number, and so forth. So it means this is arithmetic. But notice that this is the finite series because we know the last term. A finite series is a series whereby we know the last term. It means this series ends somewhere. But another thing that we should understand is that we don't know the number of terms. We can see that this is 5, 8, 11, 14, 17, and then it continues, because you can see that these 3 dots means that this series keeps on continuing. But this is the last term. It means we don't know how many terms are there in the series. So we can find the number of terms because we know the last term. For us to solve this question, we are going to find the sum of this series. This is step number 1. We find the sum of this series because this series contains the numbers that are divisible by 5 and then also that are not divisible by 5. Because 5 is divisible by 5, 8 is not divisible by 5, 11 is not divisible by 5, 14 is not divisible by 5, 17 is not divisible by 5, but there are also numbers after 17 that will be divisible by 5. So it means if we can find the sum of this series, we will be finding the sum of the numbers that are divisible by 5 and then also that are not divisible by 5. But based on this question, it says we must find the sum if all the numbers divisible by 5 are removed. So this will mean that we should also go out and identify the numbers that are divisible by 5, and then from there we should find the sum of those that are divisible by 5 so that we can be able to remove them from this series, because this series contains both that are divisible by 5 and then with also that are not divisible by 5. So let's first find the sum of this series. Because this is arithmetic, we can easily say Sn equal to n over 2, and then this is a plus l, because we know the last term. So this is our last term. But remember that we don't know how many terms we are adding there. This is a sum, we are adding these numbers, but we don't know how many numbers we are adding. So it means we should find the number of terms. We can easily find the number of terms because we know the last term. So we can say so we know the last term, this is 362, and then our first term is A, and then our common difference is 3. So from there you can say 362 minus 5, and then 362 minus 5, it will give you 357. And then you can multiply out the bracket, or you can divide by 3. So I will divide by 3, and then this will give me 119. So 119 equal to n minus 1, and then from there you can solve for n. So n equal to 120. And then now, because we know the number of terms, so it means we are adding 120 terms. So now we can say S 120, this is 120, and then over 2, and then our A is 5, and then our last term is 362, and then from there the answer gives us 22020. So this means this is the sum of this series, and then we know that for this sum we have the numbers that are divisible by 5, and then also that are not divisible by 5. So this is our first step, and then now let's see what to do from here. So what we can do from there is to identify the numbers that are divisible by 5. Remember that if this is 5, so it means this is 5, and then it will be 8, 11, 14, 17, 20, 23, 26, 29, 32, 35, and so forth. So we can first identify the numbers that are divisible by 5, which is 5, and then from there you can see that 20 is also divisible by 5, and then also 35 is divisible by 5. So it means we have these numbers. Our first 3 terms, it's 5, it's 20, and then is 35. These numbers are divisible by 5, and then from there we can find the last term. Remember, this 362 is not divisible by 5. So what we can do is to work backwards. Remember, when we were moving in this direction, you were adding 3 each time. So this was 5, 8, 11, 14, 17, and so forth. So now we want to go backwards so that we can check a number that is divisible by 5. If we go forward by adding, it means by going back we should subtract. So what you can notice is that you're having 362, and then you will have 359, we subtract by 3, and then you have 356, and then you have 353, and then you have 350, and then this number is divisible by 5. So it means our last term will be 350. So this will be our last term. So actually here we are having the numbers that are divisible by 5. So we have 5, we have 20, we have 35, and then our last term is 350. So what we can do from there, we can try to find the sum of this series, because now this series only contains the numbers that are divisible by 5. So if you can find the sum of this series, we know that we are going to subtract this from that numbers that contains everything divisible by 5, and then that are not also divisible by 5. So let's find the sum. You can notice that this is also arithmetic because we have the common difference of 15. So we are going to say Sn equal to n over 2, and then this is a plus l. But we still don't know the number of terms, so we can do the same. We can say Tn equal to a plus n minus 1 and then times d. So our last term is 350, and then our a is 5, and then our common difference is 15, and then from there 350 minus 5, this is 345, and then you can divide both sides by 15, and then you are going to get 23. So 23 equals to n minus 1, and therefore you solving for n will be 24. So this means we are ending 24 terms, and then now we can say S24 equal to 24 over 2, and then our a is 5, and then our last term is 350, and then from there what we get is 4260. So now it means this is the sum of the numbers that are divisible by 5. And then remember that we know that the sum of the numbers that are divisible by 5 and then also with that are not divisible by 5 is 22020. And then now from there we can subtract. So we can say 22020 and then minus 4260. This is because this one contains the numbers that are divisible by 5 and then also that are not divisible by 5. So now we know that this one is the one that is divisible by 5. So now we can remove it because this question said we must remove those that are divisible by 5. And then from there, the answer that we get is 11760. So this is the answer for this problem. I hope you understand.